Fantastic. So I'll be talking about bias detection and reduction, and let's just get into it. So I'll start with defining bias. One of the important things is bias is kind of, as a word, is a little overloaded. I don't mean here statistical bias or the bias of a predictor. But we'll get into that definition. Then we'll talk about mitigating bias, how you can mitigate bias in your predictive modeling. And then I'm going to give it a code example of some recent updates we have in SAS software and a little bit of discussion of the output and syntax. So what I'm going to focus here is specifically as defined on assessment of a predictive model, and I'm going to focus on classification models because that's where we have this first implemented, so bias on a classification model. And here the output and assessment on that classification model is going to be compared across groups of a sensitive variable. So sensitive variables, a lot of times we think of race, sex, gender. Those are classic sensitive variables that you might think about bias on. But I want you to kind of expand that a little bit and realize this could be anything. It could be a variable that says if you're left or right-handed, if you really cared about a predictive model that's not biased on left or right-handedness, or any sort of attribute that you can think of could be something that you reduce the bias on. Obviously, we'll usually think about the more classical examples of those variables. The model assessment is confusion matrix based. This is due to the classification models. If you were talking about assessment of regression models, of course that would not be classification matrix based, but today's discussion will be classification matrix based. Different model assessments lead to different definitions of bias, right? So if you think about your model assessments, there's the model accuracy. You might think of your type 1 error, your type 2 error. When you think of those different types of errors when looking at a model, those actually lead to different definitions, mathematical definitions of bias. Those different mathematical definitions of bias are useful or used in different scenarios and contexts. So when somebody says something that's unfair, that might mean different things mathematically depending on how you define your definition of bias. So some motivating scenarios to think about. We've seen a lot in literature or news stories about how some AI model didn't predict well based off of racial or gender characteristics. I think Brian talked this morning about models, for loans, where they said the black applicants were less likely to get a loan, right? So that's one scenario. Another scenario is, let's say you had a model that's going to say, do I want to hire someone? And you're just going to throw the data into the model, and the model says hire or not hire. Well, there's federal law about hiring, and it's the 4/5 rule. So if you have two racial groups, and one group you hire at a rate that's less than 4/5 of another group, there's an adverse impact there. So that's an actual example of where there's some legal requirements perhaps on your bias. So I've thrown up a confusion matrix here as we're going to talk about some of the bias metrics. Let's just consider a sensitive variable A or B, so not talking about any specific race, sex, gender, or anything, but just A or B. Those are the two categories. I'm going to talk about the bias of A versus B. So true positive rate, that's our recall or sensitivity. That's the number of true positives divided by the number of true positives plus false negatives. And that metric, that calculation on your model, leads to the equal opportunity bias metric as defined in some of the fairness literature. And that metric's really, you're looking at the true positive rate on the group of A versus the true positive rate on the group of B. And then you look at that difference, and if that difference is large, you're more biased. If it's close to 0, then you're less biased. Similarly, you could have, going down the confusion matrix, you could be talking about your positive predictive value. So now you're looking at the true positives, but you have a different denominator, right? And so these different metrics, this one's called predictive parity, are calculated slightly differently And you can think, hey, if I optimize my predictive parity, what does that do to my previous metrics, which I'll back up here, the equal opportunity, right? And you cannot optimize two metrics at the same time, right? Because if I'm trying to optimize for this denominator, which is the true positives plus the false negatives, and I optimize for the true positives plus the false positives denominator, those are two different optimizations in your model. And so unless you have a perfect model, those are going to be different when you're starting to look at that bias calculation. Another example is the selection rate. So this one is the true positives plus the false positives divided by the total number of observations, right? And this goes to that one we were talking about when we were talking about the 4/5 rule, right? If I had a model trying to predict hiring, you don't the law doesn't necessarily care about how accurate your hiring was if you think they were a good or a bad hire. It cares more about who did you hire. So who did you select to hire, and that selection rate gives you demographic parity. So we support assessment and mitigation on 5 different metrics. I've put the definitions here. We've got true positive rate, we have false positive rate, we've got overall accuracy on your model. Depending on what scenario you have is going to depend on what metric you want to look at. Because again, you can't optimize over multiple metrics at the same time. And whether it's your legal, your ethical, or your business requirements, those are going to be the ones that tell you where you want to look to optimize. So let's talk about mitigating bias a bit. So we've talked about the definitions. We've got 5 definitions we're looking at. Maybe we have one that we want to select. We say, okay, I've trained a model. I realize there's some bias there. I want to mitigate. What can I do? Well, sometimes bias comes in the form of I have poor data, right? And so my data collection was imbalanced. One group, I have much more data and much higher quality data than another group. Well, I could go get more data, right? That's easy. Maybe not. Maybe it costs a lot more money. Maybe your data has been collected years in the past. You can't go update that. But if you want to, one thing you could do is collect more data. This is sort of pre-processing, things you can do before modeling. Well, maybe I can sample, right? So if you're familiar with rare event modeling, one of the things that people do in rare event modeling, they might oversample the number of rare events as compared to the non-rare events. And you can do the same thing if you have one group that's much more widely prevalent in the data. You could oversample the minority group and try to balance your data that way. But if you're oversampling, you throw out a lot of other data that you don't sample in that oversampling. Well, you could weight observations. You say, okay, maybe before modeling, I'm going to weight some observations higher so that they impact the model more. And this does a good job of helping to distribute how much observations help the model, but you have to do this manually if you're going to try to do it beforehand. And how do you decide if I'm going to weight these observations or this subgroup more than that subgroup in the data? Making those choices beforehand can be difficult because you don't have the information to back that up. You can also do synthetic data generation. So I'm going to throw this out. We have our SAS Data Maker booth over there. They've talked about that on the main stage. If you want more data, maybe you can't acquire more data through the normal means of just going out and collecting more. This gets around sampling because you can generate data that you have if you have one group that you need to generate more data for. And that can also help against weighting observations. But when you train for synthetic data, you're not actually training any sort of model to reduce bias. You're really just saying, give me more data and I hope it will reduce bias. And there's a good chance that it can, but there's also a chance that it might not. So let's talk about post-processing events. I've already trained a model. I have my data. I've trained a model. I realize it's biased. What can I do after the fact? Well, I can adjust cutoffs. So a lot of models offer a predictive probability, say probability that this was a good hire or not a good hire. Well, we could say, okay, for group A, if the probability is above 0.5, we'll consider them a good hire. But for group B, if the probability is above 0.4, we'll consider them a good hire. So you could have different cutoffs for different groups. But different cutoffs are really a specific case of different models for different groups. Right? If you have a different cutoff for a group, you can kind of think of it, that's a model for one group and a model for another group. And you can do that more generally. Say I'll train a decision tree for one group and a decision tree for another group. Now you have two models. They've been trained differently. The issues there, and this applies to both, is maybe for your business you really don't want two models, one for each group. And there can be a lot of reasons why. If you're trying to do something where you're reducing a value of bias, but then you have different models, you can give off an air of, hey, I'm treating these two groups differently, right? Because I've trained two models, I'm treating them differently. And even though you're reducing that value of bias, it has a negative impact or a negative appearance. This also requires that access to that variable at training time, or at scoring time. So maybe at training time you had your sensitive group that you needed to calculate the bias for, but now at scoring time you also have to have that, and that might not always be the case. So we talked about sort of beforehand what you can do, afterhand what you can do. You can also do things sort of in the modeling process. One of the things you can do is you can just train a whole bunch of models. Train a bunch of them, tweak settings, and similar to how you might pick the most accurate model, you can also look and pick one that has low bias, and you can manually do that. But that's not really a process that's set up to specifically reduce bias. It's more if you're just manually choosing. The other thing you can do is you can turn to a model, and there are some in the literature and open source that's specifically designed to reduce the bias. And there are models that do that, but then you're locked into that model. If you're used to using maybe a more classical model or other ones for interpretability reasons or other business reasons, you might get locked into a model that you're not used to. So this is where I throw up what I'll be talking about for the last little bit here is this mitigate bias statement. So we're adding a statement in some of the modeling procedures that we have here at SAS to give you an option to say, hey, I'm going to go iteratively train that model under the covers and reduce the bias. I'll put the statement here, and you give it back. It'll still be the same model type that I'm used to, but the SAS system will have done work to mitigate the bias under the covers. So one thing I do want to point out is that if your data is really bad, any of these in-processing techniques will not work, right? You can only do so much to make up for really imbalanced or really bad data. And if your model is really bad, there's only so much you can do. So if your scenario is not good at predicting the model for anything, so rare event modeling can be pretty hard. Sometimes you get models that predict all zeros and don't predict the rare events well. Mitigating that model is not going to do very much because you already have a model that isn't particularly well suited. So the mitigate bias statement, I mentioned that it was iterative. First, if you were going to use it under the covers, it trains your model without any consideration for bias. After it trains that model, it then scores that model and looks at the bias assessments based off of whatever metric you wanted to reduce. If that's below a tolerance value or beyond a maximum number of iterations, it'll stop. But otherwise, it'll go and it'll re-weight the observations. So remember I talked about you could manually weight observations to then train a model and reduce bias, but you'd have to pick and you'd have to know how that weighting is. Under the covers, we calculate that weighting based off of the different groups and the value of the bias metric. We'll re-weight, then we go back and retrain and repeat that process multiple times. So to really kind of make it real and show you an example of what's going on, I'm going to show a code example. We'll discuss some of the syntax, some of the outputs. So here, I just have a data set. I grabbed it out of SAS Help. And here I'm just looking at whether the status is dead or alive. So it's some heart data. I've collected a few things about blood pressure, smoking status. And let's say we want to train a model that's going to be have reduced bias for male or female, right? In medical fields, male and female can maybe have important meanings, but let's say for this one, I want to have one model that has reduced bias for male and female. So maybe I would just normally go up and I'd create a random forest. I'm going to do it in code, proc forest, throw in the variables, throw in the target, and I'm going to save the save state. That's just for saving the model later, and I'm going to save my output. And that might be where I start. And then I would take that output and I would throw it into our proc assess bias. So we have an assess procedure. We also have an assess bias procedure. So that's going to look at that output that you've scored, and you give it the predicted variables that come out of the procedure, and you say, hey, here's the sensitive variable I want you to compare. What do the bias metrics look like? So there's multiple tables output. I've highlighted here the bias metrics table. This is the one that's actually going to tell us, okay, we have the male and female categories, and for the different definitions of bias that we had before, here are the calculations of that statistic. If you're thinking about, okay, I want my model to be equally accurate for male and female, hey, this is actually pretty close. It's 0.0016. But let's pretend we wanted the demographic parity. Again, that wouldn't necessarily make sense in this context, but let's pretend we want demographic parity to be lower, and that's a 0.16. We say that's too high. For our business need, we need that to be lower on our model. Well, we can come back to our proc forest and say, how are we going to add it? We're going to put this mitigate bias statement there. I put that sensitive variable that we identified before, and then I put the predicted variables and predicted events, the same ones that we put into the assess bias procedure call. And those are the ones that come out of the model when we run it the first time without any mitigation. So just by putting this one statement there, we'll get a whole host of new tables in addition to the normal forest diagnostics. But one of the easiest things to look at is this graph, right? So it's an iterative process. It trains a model, forest model, calculates the bias, updates the weights, trains a forest model, calculates the bias, updates the weights. And we can see in the blue line here, from left to right at the top left, starts about 0.16 is our demographic parity. It goes down to about 311. That's highlighted here in the legend. We also see in this case the misclassification rate started off pretty low, but kind of shot up to 0.19. So I do want to take this point to mention that when you mitigate bias, you possibly have a trade-off in misclassification rate. This is not guaranteed. Oftentimes you do, but I've also run models where both my bias and my misclassification rate have gone down. That's more likely in models that are, I would say, like random forests that are greedy algorithms. So you might make a greedy split based off of the data that actually doesn't make the overall optimal split in the larger case. Sometimes when you shake things up with mitigating bias, you can find a better global solution at the same time, but again, sometimes you can't. So this graph here helps show you, okay, I have been mitigating the bias like I want, but then you also have that sort of competing argument of maybe my misclassification rate went too high. At that point, you probably have to do a little bit of manual fiddling with figuring out, hey, what models do I want? Do I have other models? Can I change some of the parameters on the forest to get something that's a better classification rate as well as a reduced bias? So in summary, it's important that you consider your specific modeling goals when you select that bias metric. Selecting different metrics have a very different meaning in what you're asking the model to do when you reduce bias, so that's important. When you go to mitigate bias, if you're doing the in-process type mitigation, you really should train a model first and look at it because maybe it's already meeting your criteria, right? If you're thinking about the 4/5 rule in the federal employment, if you don't have that 4/5, less than that 4/5 hiring rate, you might not need to do anything. So first check, assess your model, and then go back and mitigate if you need to. It can have an overall negative impact of predictive performance, but it may not. So that's something to keep an eye out. Don't just take the lowest bias model in case you're ruining your predictive performance. Here I have the mitigate bias statement is supported in multiple procedures, and so you can come over to the machine learning booth and talk to me more, or talk to me here for a few seconds after about what procedures those are supported in. And also, I'm going to throw out a comment. There's a trustworthy AI booth over kind of on the closer to the far side of the opposite of where we are now. And they can tell you more about maybe what metrics you would want to use and when, and kind of talk you through maybe situations of types of bias that you want to think about. So that's all here. I have some documentation for the assess bias procedure and the mitigate bias statement in one of our procedures, but otherwise I think if there's any questions, I'd be happy to take them. Or feel free to corner me anywhere in the Innovation Hub. I'm here all day today, tomorrow. I'll be here Friday, even though the Innovation Hub isn't open. So if you see me walking around, feel free to come up.